Hi everyone. In this video, we are going to do word problems based on the concept of numbers. When we talk about linear equations or quadratic equations, the word problems are generally segregated into various categories. They are based on numbers, the questions related to ages, then time and distance, then time and labor. So there are various categories, right? In this video, we are going to do quadratic equations based on numbers, right? So let's quickly start with them. The first question that you can see on the screen, it's a question from an old NCRT. Guys, if you have old NCRT or if you can get from someone, it is a very good book. The word problems that were listed in old NCRT, they are actually important, still important. So if you can get that, or if you are not able to get a hard copy, you can get the soft copy from Google. You can get PDFs very easily available on Google. You just need to type old NCRT, class 10th, and whichever chapter you want, right? So I have picked up this question, which is actually from the old NCRT and based on the concept of numbers. So the question says, find two consecutive odd positive integers, sum of whose squares is 290. Okay, now we are talking about odd consecutive positive integers, multiple things. First, we are talking about integers. Second, we are talking about positive integers. Third, they are consecutive, right? So let's start. Let the first integer equals x, right? The first integer is x. Now, the next integer. We are talking about odd integers, but whether we are talking about odd or even over here, my assumption is going to be same. It's going to be x plus 2. I will not change this. Why? You will see that at the end, you will get the odd answer only because the equation is such that you don't need to take 2x plus 1 or 2x plus 1 and 2x plus 3 for odd or 2x and 2x plus 2 for even. Nothing like that. Whenever we are talking about two consecutive integers, that is x and x plus 1. But since over here we're talking about odd, so there has to be a gap of two numbers in between them. So that is why I took the first number as x, the next number as x plus 2, right? Now, what is the condition? The condition is sum of whose squares is 290, right? They are talking about the sum of whose squares. So what do we need to do? ATQ, that is according to the question, we are supposed to do x square plus x plus 2 whole square equals 290. This is what is to be done, right? Now we are going to expand. So we will have x square plus 4 plus 4x equals 290. Now how did I get x square plus 4 plus 4x? I just applied the identity of a plus b whole square in x plus 2 whole square. Okay, so adding them, we get 2x square plus 4x plus 4 minus 290 equals 0. I just collected all the terms on one side because I have to reduce it into the standard form of ax square plus bx plus c equals 0, right? So that is what we are doing over here. So that leaves us with 2x square plus 4x minus 286 equals 0. 4 minus 290 gives us minus 286. Now, what I can see, we have 2 as a common factor over here, right? I'm taking it out. That leaves me with x square plus 2x minus 143 equals 0, right? So the 2 that we have taken out will go to 0, and the standard form we are left is x square plus 2x minus 143 equals 0, right? This is what we are getting over here. So now, once we have drawn the standard form quadratic equation, it is up to us whether we apply splitting the middle term or quadratic formula. Whichever you find easier, we can apply that. Over here, we have got the number as the constant number as 143. 143, I know the factors for 143 are 11 and 13. So the splitting is actually easy, right? So I'm going to split it over here. Now, x square plus 13x minus 11x minus 143 equals 0. This is what we get because we are supposed to split, right? Now grouping gives me x times x plus 13 minus 1 is out, sorry, minus 11 is out from the last two terms, leaving us with x plus 13 equals 0, right? So that gives me two factors, x minus 11 and x plus 13 equals 0, right? The final answer, we are going to equate each of the factors with 0 and x plus 13 equals 0. What does that give? It gives me x equals to 11 and negative 13. So we have got two values of x, 11 and negative 13. Now, going back to the question, it said two consecutive odd positive integers, right? It asked for positive integers. So that means the value of x that we are getting as negative 13 has to be rejected, right? X can't be negative. Therefore, negative 13 is not possible. Okay. So we are going to conclude that x equals to 11 and therefore the next value x plus 2 comes out to be 11 plus 2 which is 13 and therefore the numbers are 11 and 13, right? See, though I started with x and x plus 2, but still I got the odd answers, right? I told you that even if you do that with x and x plus 2, the answers will be odd. It is not going to impact your answers. So you can always start with x very easily. No need to get into 2x plus 1, 2x plus 3 kind of complicated terms. Keep it simple so that the quotient remains easier. Okay. Now, moving on to the next one. The question says a two-digit number is such that the product of its digits is 18. When 63 is subtracted from the number, the digits interchange their places. Okay, such kind of questions I'm sure you must have done in class 8 in word problems of linear equation chapter, right? But in 2 years, everyone tends to forget, right? This is a question based on those kind of concepts. We are talking about a two-digit number over here. Now, quadratic equation, children are generally confused that if it is a quadratic equation, we are supposed to have only single variable. No, it is not at all necessary. Depending upon the scenario, you can always take two variables if required. And if the quotient is actually from quadratic, it will gradually convert it into single variable and a quadratic. But if it is a linear, it will remain linear. It is not going to turn into quadratic. So your two variables will not impact any quadratic equation. Okay, be confident with that. So over here, we are talking about a two-digit number. Now, how do I start? Let the tens place, tens digit equals x and units digit equals y, right? I have taken two variables over here. Tens digit is x, units digit is y, right? So now we have to form the number. In primary classes, you have learned how to form a number when you have two digits. We are always supposed to multiply with the place value. For x, the place value is 10. So therefore, the number is going to be 10 times x plus 1 times y. Therefore, just y. This is your number, that is 10x plus 1. Right? We got that? Now, according to the quotient, what it says, such that the product of its digits, okay, now they are saying the product of its digits, so x into y, that is the product, is 18 equals 18. A two-digit number, I'm reading the question again. A two-digit number is such that the product of its digits is 18. This is what I have done over here. Right. Now, the next statement says when 63 is subtracted from the number. Okay. So now what I need? 10x plus y. This is my number. When 63 is subtracted from the number, the digits interchange their places. So now, when 63 is subtracted, the digits interchange. So now, 10 times y plus x. Digits have interchanged. What we did over here, we interchanged the places, right? We are going to combine both the equations because we have got two variables, we have got two equations. So we need to sort this out very patiently and properly. Okay. So now x, 10x minus x plus y minus 10y minus 63 equals 0. This is what we get, right? So what we have? 9x minus 9y minus 63 equals 0. This is what we are getting. Okay. At this step, what I can see, I have got 9 as a common factor from x, from y, and from the constant. Okay. So taking out 9 leaves me with x minus y minus 7 equals 0, right? 9 will go to 0, right? So we are just left with x minus y minus 7 equals 0. This is our second equation. So which one was the first? The first one was this. And over here, we should be writing 80 cube because our equation started forming from this step. Okay. Okay. So now we have xy equals 18 and x minus y minus 7 equals 0. So what I'm going to do? X equals y plus 7. Ideally, I am taking this as 2 because this is to be used, right? So what we are going to do over here, we are going to substitute 2 in 1. Okay. The first equation was x into y equals 18. So y plus 7 into y equals 18. And see, you can see easily that now it is actually shaping up into a quadratic equation. So we get y square plus 7y equals 18. I just expanded the bracket, opened it up. Now, standard form y square plus 7y minus 18 equals 0, right? So we can see, we can split that easily. Y square plus 9y minus 2y minus 18 equals 0. Guys, whenever we are having such easy numbers like 18 over here, I would always recommend go for split because splitting is anytime a shorter process as compared to quadratic. I am not denying that quadratic formula is not useful. It is very useful when the numbers are complicated. But when the numbers are easy, always go for splitting. It will help you to save time and effort. And believe me, while taking up your paper, especially boards, time is a big time enemy. Okay. So try to make it a friend and save onto it. Now, grouping. We are having y out, y plus 9 in, minus 2 out, y plus 9 in, and that leaves us with two factors, y minus 2, y plus 9 equals 0. This is what we get, right? So we are having y minus 2 equals 0 and y plus 9 equals 0, right? So this gives me y equals 2 and minus 9. Now, we are talking about a two-digit number. And what is y? Y is one of the digits. It can't be negative. A digit of a number can't be negative. Therefore, y cannot be equals to negative 9, right? Hence, y equals 2. See, in the previous question also we had to reject a value. In this question also we had to reject a value. And every time I'm writing a reason. So it is compulsory to, when you are rejecting a value, there has to be a valid reason along with, right? Now y is 2. So what is going to be x? X was 18 upon y, right? So x equals to 18 upon 2, which is 9. Now the number. If x is 9, y is 2, what is going to be the number? We had assumed x to be a tens digit place. Therefore, the number comes out to be 92. Because 9 times 2 plus, 9 times 10 plus 2 gives us 92, right? Okay. Now, starting with the next question. The denominator of a fraction is 1 more than twice the numerator. Now, first of all, reading this line again, the denominator is 1 more than twice the numerator. Means we are dependent upon the numerator over here, right? So we are going to start that let the numerator be x. So what is going to be the denominator? It is 1 more than twice the numerator. So 2x plus 1, right? Fraction. Now, what is going to be the fraction? It is x over 2x plus 1, right? Now, according to the question, if the sum of the fraction and its reciprocal is 216 by 21, find the fraction. So, according to the question, fraction is x over 2x plus 1. The reciprocal 2x plus 1 divided with x. I flipped, denominator went up, numerator came down, that is the reciprocal, equals 2 times 16 by 21, a mixed fraction over here, right? Now, in the next step, I'm going to take the LCM on the left and convert the mixed fraction into improper fraction. Things will be simultaneous, right? So when we are taking the LCM on the left, x needs to be multiplied with x. 2x plus 1 needs to be multiplied with 2x plus 1. So let's start. We get x square plus 2x plus 1 whole square over x into 2x plus 1 equals. Now, 2 times 21 is 42. 42 plus 16 gives us 58 over 21. Okay. In the next step, I'm going to expand the numerator and the denominator also, applying the relevant identity on top. So it gives me 4x square plus 1 plus 4x over 2x square plus x equals 58 over 21. This is what we get. Now we need to simplify, and simultaneously I'm going to cross multiply, right? There is no point increasing too many steps being in class 10th. Okay, so simultaneously we are going to add, simplify and cross multiply. That gives us 5x square plus 1 plus 4x times with 21 equals 58 bracket 2x square plus x. I have simplified the numerator, multiplied with 21 from the denominator of the right hand side, and took the left denominator to the right and multiplied with 58, right? So what do we get now? 21 times 5 is 105x square plus 21 plus we get 84x equals 58 times 2 is 116x square plus 56x. We need to form a quadratic standard form, right? So simplifying this, now consider that I'm taking everything on the right hand side. So 0 equals 116x square minus 105x square plus 56x minus 84x minus 21. This is what we get. This gives me 11x square, and 56 minus 84 that results in 56 minus 84 is actually going to result, sorry, it was 56 or, sorry, it was 58. 58, yeah. So now it is going to result in 56 minus, this is minus 26x minus 21 equals 0, right? This is what we get upon simplification. See, the calculations can get tricky at times, but we need to be careful. Okay, the terms that we have over here is 11, 26, 21, right? So I am going to actually apply quadratic formula over here. Using quadratic formula, that is minus b plus minus b square minus 4ac upon 2a. So we are going to substitute the values, and that is minus 26 plus minus 26 whole square minus 4 times 11 times minus 21 whole upon 2 times 11. Guys, see, had I been splitting, the steps would have been over. You know that it is majorly 3 steps. But when we are applying quadratic formula, it takes a lot of steps. So now, proceeding with this, it gives me 26 plus minus square of 26 is 676. Then we have minus minus positive. What I will do, positive 11 times 4 times 21, that is 84 upon 2a, which was 22. This is what we are getting. So 26 plus minus 676 and 11 times 84 is going to result in 924 upon 22. Next, 26 plus minus 676 plus 924, that is 0, 1, 0 again, 1, we have 1600 over 22. Guys, I hadn't done these calculations before. I mean, in recent past, I am doing freshly in front of you only. So just see what I am doing and how am I doing. If you will try to be as oral as possible with your calculations, it is going to be fast. But do orderly calculations only if you are 100% confident. Otherwise, do write down your calculations. Now what we get? Square root of 1600. 40. Easy peasy. This is what we get. This is going to result in two answers. 26 plus 40 over 22. 26 minus 40 over 22. Right? Because plus minus gives us two options. Simplifying this further now. So 26 plus 40, that is what we get, 66 upon 22, and 26 minus 40, that is minus 14 over 22, right? This gives me 3 and this gives me minus 7 by 11. Meanwhile, what was the question? The question was the numerator is x, right? So the numerator can be fraction, but they're talking about a fraction over here. They're not talking about any rational number. So our numerator can't be negative. A fraction can't be negative. You have to pay attention that whether the question is talking about a fraction or a rational number. A fraction can't be negative, and therefore x cannot be equals to minus 7 by 11. So now the numerator is 3. The denominator is 2x plus 1, right? Therefore, 2 times 3 plus 1, which comes out to be 6 plus 1, that is 7. Hence, the fraction is 3 upon 7, right? So over here, we had done 3 important questions where the first question was with respect to the squares of 2 consecutive odd numbers. Then we had dealt with, in the second question, we had talked about a formation of a 2-digit number. And then in the third question, we have dealt with a fraction, how to form using a quadratic equation. And in these 3 questions, we did splitting as well as quadratic formula. So based on the equation, I always suggest go as per the flow of the question. Do not be rigid that I have to use only splitting, or do not be rigid that I have to use only quadratic formula. Be flexible as per your needs. Okay. I hope you have learned things, and do practice these questions by pausing the video, and do subscribe to the channel for further more learning videos. Happy learning!